Welcome to Petaplex. In this video, you will learn about the below things in Python. What is a class and what is an object? Storage of values for the variables. Fetching the values for the variables. Creation of multiple variables based on a single class. Calling the methods of the class through the variable. We have learned that every data type in Python is a class, and when a variable is created, Python automatically identifies the data type class for the value, and an object will be created based on the class, and the value is stored in the object's memory. We will go a little more detailed and understand what is the class and what is an object of the class. A class is a block of program code containing some logic developed for a specific requirement. The program code of a class looks like this. Inside a class, the logics are developed using various concepts of the programming language. The important concepts are methods and variables. Methods are the programming concept defined inside the class with some logics or functionality. Methods contain variables and program logics. Variables are used to store the values in the computer memory. In summary, we can say that a class is a design developed for a specific requirement. We will go through some of the examples for a clear understanding of what is a class and what is an object. We can assume a class as a design of a specific casting created inside a mold. In the mold, we have only a design of the casting available. We cannot physically touch and see the casting until a physical casting is created from the particular design. The design available in the mold is called as a blueprint. Based on the single blueprint, we can create multiple physical objects. Object means something that physically exists and can be seen and touched. All the physical castings created based on a single blueprint of the design will have the same appearance, shape, and features as well. Each physical casting may have a different paint color as different people like different colors. Let's go through another example. We can consider a class as a blueprint of a house design. Let's say we have developed a house design based on a specific requirement. Can we stay in the house using the design? No, it is not possible. First, a physical house must be constructed based on the design available, and then only we can reside inside the house. Based on a single blueprint of the house design, multiple physical houses can be constructed. All the physical houses constructed based on the single blueprint will have the same appearance, shape, and features as well. Each house may have a different paint color and different interiors based on the interest of the person staying in the house. We will look into another example now. We can consider a class as a blueprint of a car. Let's say we have developed a design for a car based on the requirement given to us. Using the design we have, can we drive the car and travel from one place to another place? No, it is not possible. First, a physical car must be manufactured based on the design we have, and then only we can drive the car and travel from one place to another place. Based on a single blueprint of a car design, multiple physical car objects can be manufactured. All the physical cars manufactured based on a single blueprint will have the same appearance, shape, and features as well. Each car may have a different paint color and different interiors based on the interest of the person using the car. In the similar way, the concept of class in programming language is just a design developed based on a specific requirement. We can consider a program code of a class as a blueprint. We cannot use the blueprint design physically for the given requirement. Based on the design, a physical object must be created, then only the physical object can be used for the given requirement. We can create multiple physical objects based on the single design of the class code. All the objects created based on a single class will have the same features and logic developed in the class. Like we can change the color of the house, casting, and car, we can change the values of each object as well while using the object. Now we will understand how to create an object for a class and what happens when the object is created. In Python, for creating an object, we must follow the below syntax. First, we should write a unique name for the object, followed by a space and an assignment operator. After the assignment operator, we must write a space followed by the name of the class for which we want to create the object. After the class name, we must specify a single pair of parentheses. A class can be designed to take some input values from the user during the object creation, or we can design a class without getting any input values from the user. If the class is designed to get some input values from the user, then we must specify the input values within the parentheses. If multiple input values need to be provided, then each input value should be separated by a comma. If the class is not designed to get any input values, then we need not to pass any values within the parentheses during the object creation. The values passed to the class during the object creation are technically called as arguments. Using this process, we can create an object manually for the class. But for the inbuilt data type classes, Python automatically takes the responsibility of creating the objects for the data type class. We need not to worry about the object creation for the data type class to store the value in the variable. Let's assume that this is the class created in Python for storing the integer values. When we create a variable like a equal to 10, then based on the value provided, Python automatically understands the given value as integer and create an object for the integer class. When a physical object is created for the int class, a specific amount of storage is allocated for the object in the computer memory. After the creation of the object, a copy of all the logic developed in the class will be stored in the memory assigned to the object. For each object created in the memory, the computer returns a unique memory address to the object. This unique memory address of the object is stored again in the memory using the name of the variable. All this process is automatically taken care by Python during the variable creation. Once the object is created, the value provided for the variable is stored in the object memory. We can use the object available in the memory for our requirement. Let's understand how to use the object created in the memory for our requirement. All the logics are developed in the class through methods only. A method is a function with specific functionality. When a function is created inside a class, then the function is called as a method. I will cover the concept of a function in detail in the upcoming session. To use an object for our requirement, we need to execute the methods available in the object. When the method is executed, the logic developed in the method will be processed and we will get a result from the method as per our requirement. A method can be designed to take some input values from the user while execution, or we can design a method to execute without getting any input values from the user. These input values of the method provided by the user while executing the method are technically called as arguments. To execute a method from the object, we must follow this syntax. First, we need to write the object name, followed by a period or dot, followed by the method name we want to execute. After the method name, we should specify a single pair of parentheses, and within the parentheses, we can pass the values or arguments to the method based on our requirement. Based on this code, we can understand that the int class has 4 methods. The name of each method is starting with 2 underscores and ending with 2 underscores. These kind of names are valid. Python followed this naming convention to differentiate the inbuilt methods from the user-created methods. ABS method is designed to take the object value stored in the memory and return the absolute value. Absolute value means positive value. The object value can be a positive number or negative number, but the ABS method will always return a positive value. In our scenario, the object value is positive number 10. The ABS method will return the output as positive 10. We don't find any difference here. In case if the object value is minus 10, then the ABS method will return the output as positive 10. Add method is designed to take a number as argument from the user, and the given argument value will be added to the object's value and return the sum of both the numbers. Now we are passing 20 as value to the add method. The object value is 10 and the argument value is 20. The sum of both the numbers is 30. LE method is designed to take some argument from the user and checks whether the object's value is less than or equal to the argument value. If the object's value is less than the method's argument's value, then the LE method returns true. If the object's value is greater than the method's argument's value, then the LE method returns false. Here we are passing 20 as argument to the LE method. The LE method checks if the object value 10 is less than or equal to 20. As 10 is less than 20, the method will return true as output. Bool method does not require any argument during the method execution. Bool method checks if the object value is a non-zero value or not. If the object's value is a non-zero value, then true will be returned. If the object's value is a 0, then false will be returned. Here, the object value is 10. As 10 is a non-zero value, bool method returns true as output. If you observe, every method has the logic developed for a particular purpose. We can execute any method based on our requirement. The purpose for which the method is designed is called as functionality. Every method will have some functionality developed. Methods are also called as functions when the methods are created outside the class. In our example, I have explained only 4 methods of the int class for your understanding. There are a lot of inbuilt methods developed under the int class for a specific purpose. Now we will understand how does an object creation happens when we create a variable with a float value. When we create a variable b equal to 59.46, based on this value, Python automatically understands the data type class for this value is float. To store the value 59.46, Python automatically create an object based on the float class and the value is stored in the object's memory. We can use the float object created in the memory by executing the methods available in the float object according to our requirement. Like integer class, float class also has a lot of methods developed for different purposes. ABS method is used to get the absolute value of the object's value. Add method is used to add a number to the object's value. LE method is used to compare a number with the object's value. If the object's value is less than or equal to the method's argument's value, then true will be returned, else false will be returned. Bool method check if the object's value is a non-zero value. If yes, then true will be returned, else false will be returned. I have shown only some methods in the float class for your understanding. There are a lot of other inbuilt methods available in the float class. Similarly, when we create a variable c equal to hello, then Python automatically identifies the data type class for the given value as string. Based on the string class, an object will be automatically created in the memory and the value hello will be stored in the object's memory. We can use the string object created in the memory by executing the methods available in the string object according to our requirement. Upper method is used to convert the object string value to uppercase. Lower method is used to convert the object string value to lowercase. LEN method is used to find the number of characters in the object string or the length of the string. MUL method is used to multiply a number with the object string value. We already know that we cannot multiply a number with a string, but however Python allows this. But the result is not an arithmetic multiplication. Instead, the string will be printed repeatedly given number of times. The value hello will be printed 5 times as output. There are a lot of methods available in the string class. We will discuss about the string class methods in detail while learning the strings concept. Now we will learn how multiple variables are created to store different integer values based on a single int data type class available in Python. We have already learned that based on a single class, multiple objects can be created with different values. Let's assume that we have created 4 variables to store 4 different integer values. A equal to 10, B equal to 20, C equal to 30, D equal to 40. Based on the integer values provided to the variables, Python automatically identifies the data type class for all these variables as int. Based on the int class, Python creates 4 different objects for each variable in the memory. Each object has its own memory allocated and the memory of one object cannot access the memory of another object even though they are created based on the same integer class. For each object, a unique memory address will be allocated and the memory address will be stored back in the memory using the respective variable names. A copy of the int class code will be stored in each object created in the memory and the values provided for the variables will be stored in the respective object's memory. All the methods available in the int class will be available in each object created based on the int class. Now we can execute all the methods of the int class through the variable a, variable b, variable c and variable d. We should remember that all the methods available in an object can access only their respective object's value. The method of one object cannot access the value of other object. For example, the APS method of variable a can access only the value 10 and cannot access the value 20 stored by the another object referenced by the variable b. In technical terms, an object is called as an instance of the class. The word instance means a single occurrence of something. As each object is a physical occurrence of a class, an object is called as an instance of the class. By now, I hope you got a good understanding of how Python stores multiple integer values through different variables in the memory. The same concept applies to each data type class available in Python. We have learned about the process of storing multiple integer values through the objects created based on the single int class. Similarly, when we create multiple variables to store multiple float values, then Python creates an object for each variable based on the float class and the float value provided to the variable is stored in the respective object's memory. Similarly, when we create multiple variables to store multiple date values, then Python creates a dedicated date object for each variable based on the date class and the given date value provided to the variable is stored in the respective date object. Similarly, when we create multiple variables to store multiple timestamp values, then Python creates a dedicated datetime object for each variable and the timestamp value assigned to the variable is stored in the respective datetime object. Similarly, when we create multiple variables to store multiple string values, then Python creates a dedicated string object for each variable based on the string class, and the string value assigned to the variable is stored in the respective string object. Here, I have shown the examples only for 5 data types. We have already discussed about multiple data types available in Python. The same process is applied for every data type class available in Python. If you observe, every single value is stored in Python as an object. Hence, it is said that everything in Python is an object. As of now, we have understood how does Python store the values in the memory for the variables. Now we will understand how does Python get the values stored in the memory for the variables. Let's assume that we have created 3 variables, a equal to 10, b equal to 20.67, c equal to hello. We have already learned the process of storing a value for the variable in the memory. First, an object will be created for each variable based on the type of value provided to the variable, and the value is stored in the respective object. The memory address of the object or the object ID is stored again in the memory using the variable name. Let's consider that the variables a, b, and c are used in the program within some logics. During the execution of the program, the Python interpreter first reads the object ID stored by the variables in the memory. Based on the object ID, the interpreter identifies the respective object in the memory and read the value stored in the respective object. The variable names used in the program logics will be replaced with the actual values read from the memory. After replacing the variable names with the actual values, the logic will be evaluated and the final result will be calculated. I hope you got an understanding of how the values are stored in the memory for the variables and how the values are fetched from the memory for the variables. Now let's understand how can we store multiple values of different data types in the same variable in Python. In the other programming languages like C, C++, and Java, once a variable is created with a specific type, we cannot store a value of other types in the variable. This kind of restriction is not there in Python. Python provides us a flexibility to store any type of value in the same variable within the same program without any limitation. Let's understand how does Python allow us to store multiple types of values in the same variable in the program. Let's assume that we have declared a variable a equal to 10. Python creates an integer object and stores the value 10 in the memory, and the memory address of the object is stored in the variable a. At this point, when the program looks for the value of the variable a in the memory, then the program gets the value as 10. Let's assume that we have assigned a new value 20.67 to the variable a in the same program. In this scenario, Python creates a new float object in the memory and stores the value 20.67. The memory address of the new float object is stored in the variable a, overwriting the previous memory address. At this point, when the program looks for the value of the variable a in the memory, then the program gets the value as 20.67, not the previous value 10. Let's assume that we have assigned a new value hello world to the variable a in the same program. In this scenario, Python creates a new string object and stores the value hello world in the object storage. The memory address of the new string object is stored in the variable a, overwriting the previous memory address. At this point, when the program looks for the value of the variable a in the memory, then the program gets the value as hello world, not the previous value 20.67. Let's assume that we have assigned a new date value October 9, 2024 to the variable a in the same program. In this scenario, Python creates a new date object and stores the value October 9, 2024 in the object memory. The memory address of the new date object is stored in the variable a, overwriting the previous memory address. At this point, when the program looks for the value of the variable a in the memory, then the program gets the value as October 9, 2024, not the previous value hello world. In this example, we can observe that we are dynamically changing the type of the values in the variable without any restriction. Hence, Python is called as dynamically typed language. The objects which are storing the values 10, 20.67, hello world are not useful anymore because we don't have any variable to track the memory address of these objects. The values 10, 20.67, hello world, which doesn't have a variable associated, are called as garbage values. Python automatically tracks this kind of garbage objects and delete those objects from the memory to free the storage so that the new object can use this storage. This entire process of tracking and collecting the garbage values and clearing them from the memory is called as garbage collection. We already learned that for every object created in the memory, a unique memory address will be assigned for the object. Now we will learn how to get the object ID assigned to the object in the memory. To get the object ID of an object, we have an inbuilt function called ID. The ID function gets some input and return the object ID of the given input as output. We can pass a variable name as input to the ID function. The function returns the object ID of the object created to store the variable value. Let's create some variables with some values. A variable A with an integer value, a variable B with a float value, a variable C with a string value, a variable D with a date value, a variable E with a timestamp value without microseconds, a variable F with a timestamp value with some microseconds. To get the ID of the object storing the value 10, we need to pass the variable name as input to the ID function. The ID function returns the object ID of the value 10. To get the ID of the object storing the value 10.75, we need to pass the variable name as input to the ID function. The ID function returns the object ID of the value 10.75. Similarly, we can pass the other variables as input to the ID function to get the object ID of the respective value stored by the variable. We can also pass any value directly to the ID function. In this scenario, the value provided in the ID function will be first stored in the memory through an object, and then the ID of the object created for the value will be returned as output. Now we will practically create an object for the int class and use the methods of the int class on the object's value. I will create a variable int_a with value 10. The variable is successfully created. I will verify the type of the object now. We are getting the type of the variable as int class. At the backend, an object was created based on the int class and the value 10 is stored in the int object. Now I will check the ID of the object created to store the value 10. We are getting the ID of the object created to store the value 10. The object ID can be considered as the memory address assigned to the object. Now I will execute the ABS method from the int object created for the value 10. ABS method returned the absolute value of the object value 10. Python interpreter is printing the output automatically, but it is always recommended to use the print function to print the output. We need to specify the entire method execution code inside the print function. Now I will execute the add method. The add method returned the output as 30. The sum of the arguments value 20 and the object's value 10. 20 plus 10 is equal to 30. Now I will execute the LE method. LE method returned the output as true because the object value 10 is less than the method's argument value 20. Now I will execute the bool method. Bool method returned the output as true. Bool method returns true if the object value is not equal to 0. As 10 is a non-zero value, true is returned. We can also create the object for the int class manually as well. I will create an object using the int class using the object creation syntax and store a value -10. int_a_neg is the object name, int is the class name, -10 is the value to be stored in the object. The variable is created successfully. I will check the type of the object and the ID of the object. I am getting the type of the variable as int class and the ID of the object is also printed by the ID function. Now I will execute the ABS method through the int object created for the -10 value. The ABS method returns the output as +10 even though the object's value is -10. Now I will execute the add method. Add method returns the output as 10. The sum of the method's argument value 20 and the object value -10. 20 minus 10 equal to 10. Now I will execute the LE method. LE method return true because The object value minus 10 is less than the method's argument value 20. Now I will execute the bool method. Bool method return the output as true because minus 10 is a non-zero value. In the first approach, we followed the regular variable creation syntax. In this approach, based on the value provided to the variable, Python identified the data type class for the given value as int class, and based on the int class, an object is created to store the given value. In the second approach, we manually used the int class to create an object and passed the value minus 10 as argument to the int class. In this approach, as we are explicitly instructing Python to use int class to create an object, Python will create an object based on the int class and store the value in the object. As of now, we have used only 4 methods from the int class for the understanding purpose. There are a lot of methods available in the int class. To see all the methods of the int class, we can use a function called help, and within the function, we need to pass the class name as input or arguments. Now, I will pass int class as argument to the help function. We are getting all the methods available in the int class. We need to press the spacebar key in the keyboard to scroll down to the remaining pages of the help function for seeing all the methods present in the int class. If we want to exit from the help function information without going through all the pages, we need to press alphabet Q key in the keyboard. We will exit from the help function and we will get the Python prompt again to execute Python code. Now I will create a variable with float value. The variable is created successfully. Let's see which class is used to create this object and what is the ID of the object. We are getting the class as float and the ID of the object is also printed. We can also create the variable float underscore b using the object creation syntax as well. The variable is created successfully. Float underscore b is the variable name. Internally, float underscore b is used as object name. Float is the class name. 59.46 is the value will be stored in the object. Let's see which class is used to create this object and what is the ID of the object. We are getting the class as float and the ID of the object also is printed. In both the approaches, the object is created based on the float class only. This clears that we can create a variable using both the approaches. Let's execute some inbuilt methods of the float class on this variable. ABS method returned the absolute value of the object's value 59.46. Add method added the method's argument value 20 with the object's value 59.46 and returned the sum of both the numbers 79.46. LE method returned false because LE method verified if the object value 59.46 is less than the method's argument value 20. As 59.46 is not less than 20, false is returned. Bool method returned true because the object value 59.46 is a non-zero value. To see all the methods of the float class, we need to pass the float class as argument to the help function. We need to press spacebar key in the keyboard to scroll down to the remaining pages of the help function for seeing all the methods present in the float class. To exit from the help function information, we need to press alphabet Q key in the keyboard. Now I will create a variable with string value. The variable is created successfully. Let's see which class is used to create the object for the string variable and print the ID of the object created for the variable. We are getting the data type of the variable as string class and the ID of the object also is printed. We can also create the string variable using the object creation syntax as well. The variable is created successfully. str underscore c is the variable name. Internally, this variable name str underscore c is used as object name. str is the string class. Hello is the value we want to store in the memory through the object. Let's see which class is used to create the object for the string variable, and we will print the ID of the object. In both the variable creation approaches, the object is created based on the string class only. This clarifies that we can create a string variable using both the approaches. I will execute some of the methods of string class through the string object created for the value hello. Upper method converted the object value to uppercase and printed the object value in the uppercase letters. Lower method converted the object value to lowercase and printed the object value in the lowercase letters. len method returned the number of characters present in the object value hello. In the word hello, we have 5 characters, hence 5 is printed as output. mul method printed the object value 5 times. To view all the methods of the string class, we need to pass string class as argument to the help function. We need to press the spacebar key in the keyboard to scroll down to the remaining pages for seeing all the methods of the string class. We need to press alphabet Q key to exit from the help function. Based on the variables created till now, two things will be clear. The first thing is, when a variable is created, an object is created at the backend to store the value provided to the variable. The second thing is, all the methods present in the underlying class of the object can be executed through the object on the object's values. Now, I will create 4 different variables with 4 different integer values. All the variables are created successfully. I will verify the underlying data type class for all these variables. We are getting the data type as int class for all these variables. I will verify the ID of each object created for these variables. For every object, a unique memory address or unique object ID is returned as output. This conveys that for each variable, an object is created based on the int class and the value is stored in the respective object storage. Here, we need to understand that based on a single int class, 4 different objects were created. Now, I will verify whether the methods present in the int class are available in all the 4 objects created based on the int class. I will execute some of the int class methods through the variable int underscore a. I am able to execute the methods successfully. Now, I will execute the methods through the variable int underscore b. All the methods are executed successfully. I will execute the method through the variable int underscore c. All the methods are executed successfully through the variable int underscore c. I will execute the methods through the variable int underscore d. All the methods are executed successfully through the variable int underscore d. We are able to execute the methods of the int class through each object created based on the int class. This practical clears that the methods and logic developed in the int class can be executed through each object created based on the int class. Now, I will create 4 variables based on the float class. All the 4 variables are created successfully. Now, I will check the type of each object created for these variables. We are getting the data type of all these 4 variables as float class. Now, I will find the ID of each object created for these 4 variables. We can observe that each float object has its own unique memory address. I will execute some of the float class methods through the variable float underscore a. We are able to execute the methods of the float class successfully through the object created for the variable float underscore a. I will execute the methods through the variable float underscore b now. The methods are executed successfully and we got the output from each method. I will execute the methods through the variable float underscore c. The methods are executed successfully through the variable float underscore c. I will execute the methods through the variable float underscore d. The methods are executed successfully through the variable float underscore d. The learning here is we are able to execute the methods of the float class through each object created based on the float class. Now I will create 4 variables based on the string class. All the 4 variables are created successfully. Now I will check the data type of each object created for these 4 variables. We are getting the data type for all these 4 variables as string class. Now I will find the ID of each object created for these 4 string variables. We can observe that each string object has its own unique memory address. Now I will execute some of the methods of string class through the variable str_a. The methods are executed successfully through the variable str_a. I will execute the methods through the variable str_b. The methods are executed successfully through the variable str_b. I will execute the methods through the variable str_c. The methods are executed successfully through the variable str_c. I will execute the methods through the variable str_d. The methods are executed successfully through the variable str_d. We can notice that the methods developed in the string class are available in each object created based on the string class. We can come to a conclusion now that based on every class, multiple objects can be created. The methods developed in the class will be available in each object created based on the class. Now I will practically check whether we can store multiple types of values in the same variable or not. First, I will create a variable with integer value. The variable is created now. I will print the value of the variable. The value of the variable is printed as 10. I will check the type of the variable. The data type of this variable is showing as int class. I will print the ID of the object created for this variable. Now I will assign a float value to this variable. The variable is created now. I will print the value of the variable. The value of the variable is printed as 20.67, not the previous value 10. I will check the type of this variable. The data type of this variable is showing as float class currently. I will print the ID of the float object created for this variable. We can notice that the object ID is different now. Now the variable is currently storing the new object ID of the float object, not the object ID of the previous integer object. Now I will assign a string value to the same variable. The variable is created now. I will print the value of the variable. The value of the variable is printed as hello world, not the previous value 20.67. I will check the type of the variable. The data type of the variable is currently showing as string class. I will print the ID of the object stored by the variable. We can notice that the object ID is different now. Now the variable is storing the new object ID of the string object, not the object ID of the previous float object. Now I will assign a date value to this variable. The variable is created successfully. I will print the value of the variable. The value of the variable is printed as 10th November 2023, not the previous value hello world. I will check the type of the variable now. The data type of the variable is currently showing as date class. I will print the ID of the object stored by the variable. Now the variable is storing a different object ID. In Python, we are able to store different types of values dynamically in the same variable. Hence, Python is called as dynamically typed language. As of now, we have passed multiple variables as input to the ID function. Now, I will pass multiple values directly to the ID function. We are getting a unique object ID for each value provided to the ID function. When we provide a value directly to the ID function, two steps happens internally. In the first step, based on the type of value provided to the ID function, Python creates an object and stores the value in the object. In the second step, the ID of the object is returned by the ID function. I hope you got a good understanding of creating variables, printing the value of the variables, checking the type of the variables, and printing the ID of the object created for the variables. Thank you for watching this video. If you are happy with the learning in this video, please like and share this video to your friends and relatives who need this learning. Do not forget to subscribe our channel and press the bell icon to get updates on our upcoming videos.